Something significant just happened at Computex 2026 that nobody in the tech world fully saw coming. Not at this scale, not with this level of aggression, and definitely not from this company. NVIDIA, the company that makes the graphics chips powering the world's most powerful AI data centers. The company behind the CUDA platform that essentially runs the modern AI industry, the company whose GPUs sit inside every major cloud provider, training the models that millions of people use every single day. That company just announced that it's making its own processor for your laptop. And not just any processor, a complete system on a chip, CPU, GPU, and unified memory, all fused together into a single package, designed from the ground up to run Windows, run AI models locally, run AAA games at 1440p, above 100 frames per second, and handle professional creative work like editing 12K video and rendering massive three-dimensional scenes, all in a thin laptop, all on a single chip. They're calling it RTX Spark. And the comparison that every single tech outlet reached for immediately, the comparison NVIDIA itself is clearly inviting, is Apple Silicon. Because for the last several years, Apple's M-series chips have been the undisputed benchmark for what a unified, power-efficient CPU plus GPU system on a chip can do in a laptop. When Apple launched the M1 back in 2020, it didn't just impress people, it embarrassed the rest of the industry. Battery life doubled overnight. Performance jumped dramatically. Fans barely spun. The machine ran cool and quiet, doing tasks that used to heat up Intel chips significantly. Apple redefined what people expected from laptop performance and then kept compounding that advantage with M2, M3, M4, and now M5. They showed the world that you didn't need a hot, loud, battery-draining, discrete GPU to get serious computing done on the go. And for years, the Windows world had no real answer. Intel tried. Qualcomm tried with their Snapdragon X chips. AMD tried. All of them made genuine progress. None of them landed a knockout blow against Apple's approach. Then NVIDIA walked onto the stage in Taipei and said, "Our turn." So what exactly is RTX Spark? Well, let's get into the actual details, because the specs here are genuinely remarkable and worth understanding properly before talking about what they mean in practice. At the heart of it is what NVIDIA is calling the RTX Spark superchip. It packs a 20-core Grace CPU, an ARM-based processor that NVIDIA co-developed with MediaTek, a strategic choice that's worth noting because MediaTek has no competing GPU business, meaning there's no conflict of interest in the partnership, alongside a Blackwell architecture GPU containing 6001 144 QDA cores with 5th-generation tensor cores that support FP4 precision. Those two components are connected internally via something called NVLink C2C, running at 600 gigabytes per second. That interconnect is the same technology NVIDIA uses inside its data center hardware. The same. Interconnect that makes Grace Hopper superchips perform the way they do in hyperscale AI infrastructure. And sitting on top of all of that is up to 128 gigabytes of unified LPDDR5X memory, with 300 gigabytes per second of memory bandwidth. The whole thing is built on TSMC's 3nm process node, the same cutting-edge manufacturing that Apple uses for its own chips. To understand why those numbers matter, you need a bit of context. The CUDA cores and tensor cores inside RTX Spark are not some cut-down, power-reduced shadow of real Blackwell performance. NVIDIA claims that the integrated GPU inside this chip is comparable in capability to the RTX 5070 laptop GPU, a discrete graphics card that, just months ago, would have required its own separate silicon, its own dedicated GDDR7 memory, its own power budget, and a thicker, heavier chassis to house it. That level of GPU performance is now integrated into a unified chip, sharing memory with the CPU in something thin enough to put in a slim laptop. NVIDIA is specifically promising 100 frames per second gaming at 1440p. Resolution, enabled by DLSS 4.5 upscaling and multi-frame generation, the technology that synthesizes multiple additional frames for every frame the GPU actually renders natively. Confirmed game support already includes Alan Wake 2, Marvel Rivals, PUBG, Valorant, and League of Legends. And for creative workloads, the large unified memory pool means you can work with truly massive files. 90 gigabyte three-dimensional scenes for game development or film production, 12K video editing at full resolution, without constantly hitting memory limits and waiting for assets to swap in and out. The AI performance number NVIDIA is leading with is 1 petaflop at FP4 precision. 1 petaflop. That is data center class artificial intelligence compute in a laptop. Now, let's talk about where the Apple Silicon comparison gets interesting, genuinely fascinating actually, and where it gets complicated. On the surface, the hardware spec sheet for RTX Spark and Apple's M5 Pro looks surprisingly similar in broad strokes. Both are ARM-based. Both have around 20 CPU cores. Both have a large integrated GPU and unified memory. Both are aimed at the same category of user: professionals, creators, and power users who want serious performance without carrying a workstation around. If you squint at a spec sheet comparison, you might think these are the same class of product wearing different logos. You'd be wrong. Dig a layer deeper, and the differences become stark. And they go in both directions, which is exactly why the framing of this as a simple NVIDIA wins, Apple loses story is too simplistic to be useful. RTX Spark has a genuine, meaningful, and arguably unprecedented advantage in raw GPU muscle. 6,144 CUDA cores, 5th generation tensor cores, full ray tracing, path tracing, DLSS 4.5 support, G-Sync, Reflex. This is the same GPU technology stack that currently powers the best gaming and professional graphics cards in the world, just in an integrated form factor. Apple's M5 has a powerful GPU, but it does not have CUDA. It does not have tensor cores in the NVIDIA sense. It does not support DLSS. It cannot do path tracing in the way RTX hardware can. For any workload that specifically benefits from CUDA, which includes most professional AI development, most neural network fine-tuning, most high-end video pipelines built around NVIDIA's acceleration tools, and the entire universe of software that's been CUDA optimized over the last 15 years, RTX Spark has no direct competition in the Apple laptop lineup. Period. Apple Intelligence runs a 3 billion parameter on-device model. RTX Spark can handle models between 10 and 50 times larger, locally, without sending a single token to the cloud. 120 billion parameter models, locally, on a laptop. That's not a marginal improvement in AI capability. That's a different category of what a laptop can do. The memory story is similarly aggressive. 128 gigabytes of unified memory in a laptop is not a spec that exists anywhere else at this price tier. Apple's M4 Ultra, which maxes out at 192 gigabytes, costs well over $5,000 and sits inside a desktop machine. RTX Spark brings 128 gigabytes to a laptop form factor, which means running local large language models with context windows stretching to 1 million tokens becomes a workload you can do from a coffee shop. On the CPU side, though, the story is more nuanced. And this is where critics of the NVIDIA just slapped Apple framing have a legitimate point that deserves honest engagement. Early benchmark data, including a Clang compilation benchmark that circulated shortly after the announcement, shows RTX Spark's 20-core Grace CPU scoring around 43,000 points, which puts it roughly 54% ahead of the 10-core Apple M5. That sounds dominant until you realize the M5 Pro, Apple's mid-tier chip in that same family, comes out ahead in the same test. RTX Spark sits between the base M5 and the M5 Pro in raw CPU performance. That's genuinely impressive for a first-generation entry from a company that has never made a consumer CPU before in its entire history. But it's not a massacre, and it's worth being honest about that. Part of the reason is that while RTX Spark has more CPU cores, some early analysis suggests those ARM cores are based on designs that trail Apple's current CPU architecture in terms of per-core efficiency and single-threaded performance. One Apple-focused analysis noted that on the CPU front specifically, NVIDIA's chip is comparable to Apple hardware that's more than 2 years old. Apple has been refining its custom CPU cores across multiple generations, with access to TSMC's most advanced nodes and a vertically integrated hardware-software stack that provides optimization advantages that take years to replicate. Apple also has memory procurement advantages that matter more than people realize. The company buys LPDDR at volume years in advance, integrated directly into its SoC supply chain. NVIDIA and its OEM partners are buying the same LPDDR5X memory into an active shortage without that same supply chain position. In a tight memory market, Apple's bill of materials is locked while NVIDIA's is exposed, and that gap potentially widens Apple's cost and availability advantage over time. One technical analysis that went somewhat viral in developer circles after the announcement put it plainly and clearly: RTX Spark is not an Apple Silicon competitor in the traditional sense. It's a different product, aimed partly at the same buyer, but built around a fundamentally different set of strengths and designed for a different platform with a different set of constraints. CUDA matters enormously for AI development on Windows. The memory advantage matters for LLM inference at scale. The GPU gaming performance matters for the huge portion of laptop buyers who want to play games. But for someone who mostly runs macOS native creative apps, who does their AI work through Apple's own frameworks, and who doesn't need CUDA at all, and there's a real software challenge waiting in the wings that's easy to underestimate from the outside. One of the biggest reasons Qualcomm's Snapdragon X effort never fully broke through for gaming and certain creative workloads was application compatibility. Running x86 software through an ARM translation layer works much better than it used to. Windows 11 has improved translation dramatically over the past few years, but it's not seamless for every application, and for certain specialized software, translation overhead remains noticeable. NVIDIA is stepping into that exact same challenge. The software ecosystem catch-up is real work that takes real time, and NVIDIA is betting that its brand recognition, its developer relationships built over decades through CUDA, and Microsoft's own heavy investment in Windows on ARM will clear that path faster than Qualcomm managed to. That bet might genuinely pay off this time around. NVIDIA is a much more powerful partner for Microsoft than Qualcomm was, but it's still a bet, not a guarantee. To that end, to be clear, NVIDIA isn't going it alone on the software side of this equation. The company announced at Computex that Adobe is rebuilding core parts of Photoshop and Premiere Pro from the ground up specifically for RTX Spark, targeting 2 times faster AI performance on these applications. Blender is being rebuilt for it. NVIDIA has also introduced something called OpenShell, a new runtime for Windows that handles local AI agents natively on the device, alongside an agent toolkit built for developers who want to build agentic applications that run entirely on local hardware. And NVIDIA claims the new NemoClaw system gives those agents the ability to set goals, call tools, evaluate the quality of their own output, and refine it, all running on the device in your bag, not in a server rack somewhere. The vision here is that RTX Spark isn't just a faster chip, it's an entire new computing paradigm where AI agents live on your laptop, understand context across your applications, complete multi-step tasks autonomously, and keep your data private by never leaving the machine. It's a vision of local AI that's genuinely more ambitious than anything Apple or Qualcomm have articulated at this scale. The market reaction was immediate and revealing. When the RTX Spark announcement landed, shares of Intel and AMD slid noticeably, a signal that investors understand exactly what it means when the world's most valuable semiconductor company decides to enter your core market directly. NVIDIA isn't just competing with Apple here, it's competing with Intel for Windows laptop CPUs, with AMD for Windows laptop processors, and with Qualcomm for Windows on ARM, all at once. That's an extraordinarily bold move, and the stock market priced it in within hours of the Computex keynote. Microsoft is clearly all in on this in a way that goes beyond a typical technology partnership. Not only is the Surface Laptop Ultra one of the first confirmed devices with RTX Spark inside, meaning Microsoft is betting its own flagship hardware line on this platform, but Microsoft's blog described the joint announcement as a key milestone in a rich, full-stack collaboration spanning gaming, AI, and cloud infrastructure. The Windows on ARM story has never had this kind of heavyweight partner before. Qualcomm brought solid chips, but neither Qualcomm nor any previous ARM partner brought CUDA, tensor cores, a generation-defining GPU architecture, decades of developer relationships, and a globally recognized brand that commands premium pricing and genuine developer attention. NVIDIA brings all of that simultaneously, and it's publicly committing to 3 generations of Spark platforms to prove it's serious about this for the long term, not just as a one-generation experiment. Jensen Huang announced that NVIDIA will ship at least 2 more generations of Spark chips beyond the current Grace Blackwell, Vera Rubin, which will use LPDDR6 memory, followed by Rosa Feynman. That's a multi-year, multi-generation commitment to this platform, and it's exactly the kind of signal that OEM partners and software developers need before they sink serious resources into building for a new architecture. NVIDIA is trying to eliminate that uncertainty by putting the roadmap on record publicly, on stage, at the biggest computing trade show of the year. It's a credibility move as much as a technical one. Speaking of OEM partners, the list of companies building RTX Spark laptops this fall is essentially the entire Windows laptop industry. And the breadth of this commitment is itself one of the most significant signals about the platform's credibility. Asus is bringing 2 ProArt models targeting creative professionals, the P16 and the P14, covering both large screen and more portable options. Dell is releasing an XPS 16 Creator Edition, a notable choice given the XPS line's reputation as one of the most premium Windows laptop families. HP has the OmniBook Ultra 16 and OmniBook X14 covering different form factor preferences. Lenovo has the Yoga Pro 9N for its creator-focused lineup. MSI has the Prestige N16 Flip AI Plus, going after professionals who want convertible flexibility. Microsoft itself is releasing the Surface Laptop Ultra, betting its own flagship consumer hardware on this new platform. Acer and Gigabyte are confirmed to follow shortly after launch. The sheer coordination of this rollout, 8 confirmed machines from 6 different manufacturers hitting simultaneously in the same seasonal window, is something the Windows on ARM ecosystem has simply never achieved before at this scale. Pricing hasn't been confirmed officially by NVIDIA, but analyst notes from Morgan Stanley suggest entry-level RTX Spark laptops starting around $1,799, with the higher-end configurations featuring the full 128 gigabytes of unified memory potentially landing around $2,899. That puts these devices firmly in the premium tier, competing directly with the MacBook Pro M5 Pro and M5 Max, which occupy a very similar price range. The initial audience for RTX Spark is deliberately targeted at professionals, AI developers, and serious creators who already spend significant money on their portable computing setup. And that's where the real competitive battle gets genuinely interesting. At that price point, $1,700 and up, you have a real choice between two fundamentally different philosophies of what a laptop should be. On one side sits Apple Silicon, macOS, a mature and deeply optimized software ecosystem refined across 6 hardware generations, arguably the best battery life in the industry at this performance tier, and a CPU architecture sharpened year after year for efficiency and single-threaded speed. The M5 is a known quantity with thorough, consistent reviews and years of developer optimization behind it. They are genuinely remarkable and worth understanding properly before talking about what they mean in practice. At the heart of it is what NVIDIA is calling the RTX Spark superchip. It packs a 20-core Grace CPU, an ARM-based processor that NVIDIA co-developed with MediaTek, a strategic choice that's worth noting because MediaTek has no competing GPU business, meaning there's no conflict of interest in the partnership, alongside a Blackwell architecture GPU containing 6001 144 QDA cores with 5th-generation Tensor cores that support FP4 precision. Those two components are connected internally via something called NVLink C2C, running at 600 gigabytes per second. That interconnect is the same technology NVIDIA uses inside its data center hardware. The same interconnect that makes Grace Hopper superchips perform the way they do in hyperscale AI infrastructure. And sitting on top of all of that is up to 128 gigabytes of unified LPDDR5X memory, with 300 gigabytes per second of memory bandwidth. The whole thing is built on TSMC's 3nm process node, the same cutting-edge manufacturing that Apple uses for its own chips. To understand why those numbers matter, you need a bit of context. The CUDA cores and Tensor cores inside RTX Spark are not some cut-down, power-reduced shadow of real Blackwell performance. NVIDIA claims that the integrated GPU inside this chip is comparable in capability to the RTX 5070 laptop GPU, a discrete graphics card that, just months ago, would have required its own separate silicon, its own dedicated GDDR7 memory, its own power budget, and a thicker, heavier chassis to house it. That level of GPU performance is now integrated into a unified chip, sharing memory with the CPU in something thin enough to put in a slim laptop. NVIDIA is specifically promising 100 frames per second gaming at 1440p. Resolution, enabled by DLSS 4.5 upscaling and multi-frame generation, the technology that synthesizes multiple additional frames for every frame the GPU actually renders natively. Confirmed game support already includes Alan Wake 2, Marvel Rivals, PUBG, Valorant, and League of Legends. And for creative workloads, the large unified memory pool means you can work with truly massive files. 90 gigabyte three-dimensional scenes for game development or film production, 12K video editing at full resolution, without constantly hitting memory limits and waiting for assets to swap in and out. The AI performance number NVIDIA is leading with is 1 petaflop at FP4 precision. 1 petaflop. That is data center class artificial intelligence compute in a laptop.